Hey everyone, this is Esther here. Welcome to my channel. How are you guys doing? I hope you all are doing absolutely amazing. So today we are starting this chapter, statistics. This is your chapter 14 from your NCERT math textbook. Today we're going to be seeing the intro to this chapter part 1, meaning there's going to be another part 2 to this chapter's introduction. So with that short note, let's get started. So this is a little bit of a lengthy chapter, I would say, but I feel it is a little bit easy. It's very easy, I would say, because you have learned all these things before as well. So this is going to be like a kind of continuation, you can say. Few more new things as usual we are going to be adding to the already known concepts, and that's the basic thing about this chapter. So first of all, let me teach you what is statistics. You see this big word on your screen, right? What does this word means? Now, a little bit of history about statistics. What is statistics? Basically, the word statistics appears to have been derived from the Latin word status or status, whatever you say, meaning a political state. In its origin, statistics was simply the collection of data on different aspects of the life of people useful to the state. Over the period of time, however, its scope broadened and statistics began to concern itself not only with the collection and presentation of data, but also with the interpretation and drawing of inferences from the data. In simple words, if I tell you what is statistics, basically statistics deals with the collection, organization, analysis and interpretation of something called as data. Now, before we understand this definition, let us first of all see what is data. Now, data in simple words is facts or figures. Suppose, for example, if I collect the height of 20 students of your class, then that would be data because it gives us facts, right? Your 20 students have some particular height, which is a fact, or it is a figure, numerical figure. Similarly, the number of absentees in each day in your class for a month, number of members in the families of your classmates, all these things are examples of what? Data. So data is nothing but the facts or figures, right? So I hope you understand what is the meaning of data. Coming back to what is statistics, basically whenever we collect data, we organize it in a proper manner, in a grouped manner, and we analyze the data, okay, on some particular topic, right? On some particular basis, we analyze the data, and on that basis, when we interpret the data, we call that as statistics in simple words, okay? So this is called as statistics. Clear? Now, speaking of data, we have two types of data, that is primary and secondary. Now, what is all of this primary and secondary? Let us see. Okay, primary data, this is for primary data. So primary data is basically when the information was collected by the investigator herself or himself with a definite objective in his or her mind. The data obtained is called as primary data. So what does this mean? Basically, let us understand this through an example. Suppose I am the investigator, let's say, and I want to collect the the marks obtained. Okay, Esther, that is me, collected the marks of 9A students, okay, for a survey. I collected this, okay. Now when I'm doing this task on my own, I'm not using any source to collect the marks. In fact, I'm going to each student of 9A and I'm asking, what is your marks that you scored, let's say in term 1. Okay, of term 1, I'm going and collecting for a survey. For my own purpose, I have with this definite objective, I'm collecting it. This is an example of primary data. Now the difference that secondary data gives us is, this is secondary data, okay. But the difference in secondary data is when the information was gathered from a source which already had the information stored, the data obtained is called secondary data. Let's say there is a second person called Meera. Now Meera also wants the marks of 9A students, marks that are scored by 9A students in term 1. She also wants it for her own purpose, for her own analysis or survey or whatever, for her own objective. Now she doesn't need to go and collect, right? She can ask me. So when Meera collects the data from Esther, or you can say it collects the already gathered data from Esther, that is from me, this is called as the secondary data. Okay, why am I saying it's secondary data? Because Meera is collecting the already gathered information from me. She's not directly going and doing everything on her own, right? She's already collecting it from a source, that is me. But when I, Esther, am collecting the marks of 9A students for my own purpose by myself, I'm not using any source, that is called as primary data. Is this clear, right? I hope that this is clear. What is primary data, secondary data? In simple words, primary data is when the information is collected by a person directly without using a source, is called as primary data. Whereas secondary data is when the information is collected by a person from a source. From a source in the sense, from a source that is already having the required information. Basically, that is the meaning of secondary data. I hope this is clear. Now, we have learned what is data and what are the types of data. Now we also need to present this data. Am I right? Now as soon as the work related to collection of data is over, the investigator has to find out ways to present them in a form which is meaningful, easily understood, and gives its main features at a glance. So whenever suppose I finish collecting my data, now I need to present it in such a way when it is meaningful and it is easily understood and it gives its main features as soon as I look at it. Now we can present data in two ways. Okay, grouped data. One second, here let me write data presentation can be of two types: ungrouped data and group data. Now we will see each of this in detail. Okay, now first let us start with ungrouped data. When data is in its original form after it is collected, we call this as ungrouped data, right? Now I'm just randomly I've started collecting. For example, random collection of students of 9th standard, of 30 students of 9th standard. Okay, I'm just randomly collecting it. Okay, and when I present this data as it is, we call this as a raw data as well. Raw data meaning it is in its original form, there is no change in it, right? So this is called as the raw data, and we call this as ungrouped data as well, raw data or ungrouped data as well. And we also have an example here, that is marks obtained by 30 students in a class test. I missed out this example, I would have used this instead of what I wrote, but anyway, it's okay. Marks obtained by 30 students in a class test. Now another very important concept is a range. What is a range? Now sometimes in exam you can get a question, calculate the range of this particular data. So how will you do this? So let me teach you what is a range using an example. So basically, what is range? The definition is the difference between the highest and lowest number of data is called the range. Okay, for example, here let me write, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now these are numbers that are collected. Okay, this is the data. Okay, this whole set is the data basically. Now if I have to find the range of this data according to the definition of range, what is it? Basically it's the difference between the highest and the lowest value. And in this data that I have written in front of you, what is the highest value? 10. What is the lowest value? 1. right? Now if I have to calculate the range, what will the range be? It will be the highest value, highest minus lowest. So that means here range will be 10 minus 1, which is equal to 9. Is this clear? What is range? Simple, right? Range is the difference between the highest and lowest values of the data. We call that as range. Now we have something called as frequency distribution table. Okay, but first of all, what is frequency? I have not written the definition here, but I will orally tell it to you. The number of times an observation occurs in the given data is called frequency of that observation. Okay, basically in simple words, number of times an observation occurs in a given data. Now in this table, on the side I have put one table. No, in this table you can see that I have number of students, that is the frequency here, and I have the marks. Now according to the definition of frequency, what is the frequency of 60 marks? What is the frequency of 60 marks? So how many students have got 60 marks? 4. So basically the frequency is 4, because that is the number of times this observation occurs, right? So 4 is the frequency of this particular number, that is 60. Understood what is frequency? Now what is a frequency distribution table? What does this mean? Again, let me tell you the definition of this. So basically a frequency table or a frequency distribution table is the table in which numerical data for particular variate with their frequency is shown. Meaning here, okay, we will have some particular number here, like marks, numbers, scores, class intervals, all of that in one side we will have, whereas the other side will have its frequency. Like here you can see the marks, let's say marks obtained in the class test, and all the marks have been given here, as well as the number of students, that is the frequency that is occurring, has been given here. So in a frequency distribution table, on one column we will have a particular variate, we will have a particular column having the marks, numbers, the class intervals, as I told you, etc, etc, whereas on the other side we will have its respective frequency. This is a frequency distribution table. I hope it is clear. This is all about, we need to learn about the ungrouped data. Now when we come to group data is basically used to present the very large number of items in a data using a grouped manner. Okay, so when we have large number of items, we have to present it in a grouped format, right? For that we use a grouped distribution table. Under group distribution table, we need to learn 5 very important concepts or 5 very important things in a grouped distribution table. Alright, now in a group frequency distribution table, first of all we have 2 types of this. Okay, continuous frequency distribution and discontinuous frequency distribution. Continuous frequency distribution is if the upper limit of one class is the same as the lower limit of the next class, then it is said to be exclusive or continuous frequency distribution. You might be wondering what is upper limit and lower limit. I mean, if you do not know what it is, right? So let us first understand what is upper limit and lower limit. Wait one second. Okay, I'll explain it right here. So before we learn upper limit and lower limit, let me tell you what a class interval is. A class interval is used to present a large amount of data more meaningful, very divided into various columns with minimum and maximum values. Such groups are called classes or class interval. Basically, let's take this previous table. Okay, we don't have a frequency table here. Fine. Okay, I will make a table here for you. Let's say 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, and let's say this is the marks, again marks, and we have the frequency here. Frequency here, let's say 5, 10, 15, 20, 25. So what is the total? 5, 10, 15, 2, 4, 5, 6, 7. 75 is the total frequency. Am I right? So basically all these intervals, we call this as intervals. This particular thing, all these are one class intervals. Okay, each of this is separate class intervals. Now in a class interval we have something called as upper limit and lower limit. Okay, so class interval is nothing but groups with minimum and maximum values. We say upper limit is the highest value of that interval, highest value of that interval, and lower limit is the lowest value of that interval. Okay, lowest value of that interval. Fine. Of that interval means of that particular interval. So for example, if you see 0 to 10, what is the upper limit here? In 0 to 10, basically the upper limit will be 10, of course, because it's the highest value of that interval. Whereas what is the lower limit? That will be 0, because it's the lowest value. Similarly, in 10 to 20, upper limit is 20, lower limit is 10, and it goes so on. Okay, now another important thing is what is the class width or size. Okay, class width or size. The difference between the upper limit and the lower limit of a class is called its class size or class width. So basically upper limit minus a lower limit. Okay, when we subtract this, we will get the class width or size. For example, if I have to find out the class size of 40 to 50, well, how will I do that? Upper limit minus lower limit. So that will be 50 minus 40, which will be 10. Okay, that's how we find out the class width. Now also class mark. What is the class mark? We say class mark is the mid value of a class. Okay, mid value of a class. Suppose I have to find the mid value of 30 to 40. Okay, how will I do that? Using a formula, of course. So what is that formula? Let us say the formula will be class mark will be the upper limit plus lower limit divided by 2. So that means here we will have the upper limit as 40 plus lower limit 30 divided by 2. So this will be 70 by 2, which will be 35. Okay, so here the class mark will be 35. Just give me 1 second. Just give me 1 second. Alright, now I hope you understood what is the class mark, right? That is the mid value of a particular class. Now we understood these 5 things. What is class interval, upper limit, lower limit, class width, and class mark. I hope it is clear. Now I also told you that we will be coming back to the continuous frequency distribution after this, right? Now let us see. Now if the upper limit of one class is the same as the lower limit of the next class, upper limit, hope you understood, is the highest value of that particular class. Lower limit is the lowest value of the particular class. So let's take this table for example. This table on the right hand side for continuous frequency distribution. Continuous frequency distribution. Now here, if you see the first class interval, 20 is the upper limit, and in the second class interval 20 is the lower limit. So basically when we have such situations, we say that this is a continuous frequency distribution. Why? Because the upper limit of one class will be the same as the lower limit of the next class. If you see the upcoming intervals like 30 and 30, 40 and 40, then 50 and 50, then 60 and 60, you're seeing that these two are matching, right? Okay, these two are matching. So such distributions are called as continuous frequency distributions. Alright, now this continuous frequency distribution is the absolute opposite, right? If the upper limit of one class is different from the lower limit of the next class, we say that this is the inclusive or discontinuous frequency distribution. Now in this table which you can see here, this is for discontinuous frequency distribution. Now here you are seeing upper limit is not the same as the lower limit, upper limit is not same as lower limit, upper limit not same as lower limit, and you are seeing that it is different, right? When such cases arise, we say that this is a discontinuous frequency distribution. Now if we have such types of data, we need to convert it to continuous frequency distribution. Now how we'll do that that conversion, let us. So how do we make continuous class intervals? So it's very simple. Basically, as you can see in this table, we have the intervals 31 to 35, 36 to 40, 41 to 45, and so on. As you can see, the intervals are not continuous. This is a discontinuous frequency intervals. Am I right? So we cannot proceed with this type of frequency distribution. So we need to make it a continuous class interval. For this, we need to subtract 0.5 of the lower limit and add 0.5 on the upper limit of each class interval. Okay, so that means that, one second. So that means that here we will have 31 minus 0.5 will be what? 30.5, correct? And 35 plus 0.5 will be 35.5, correct? So we are putting a new table here, weights in kg, and here we have the number of students. Okay, we'll fill this number of students column later. First we will make it continuous. Similarly for 36 to 40, minus 0.5 plus 0.5. So this will be 35.5 to 40.5. As you continue to do this for the other intervals, you will get to see this final table. See, 30.5 to 35.5, 35.5 to 40.5. So everywhere you can see that we have subtracted 0.5 of the lower limit and we have added 0.5 to the upper limit. This is how we make the class intervals continuous. And also another thing, that the frequency, that is the number of students, do not change. Also another thing that I wanted to tell you is, see, basically in this frequency, let's say we have interval like 30 to 40. So this is the lower limit, and this is the upper limit, right? But do you think 40 will be included in this class interval? Let's say we have a continuous class intervals like this, 30 to 40, 40 to 50, 50 to 60. In such a case, do you think 40 will be included? No, it won't be included. In fact, it will be included in the next interval. So the upper limit of this interval, that is 40, will be included in the next interval as the lower limit. Okay, so the upper limit, whatever number is there, it won't be included in that interval. In fact, it will be included in the next interval. So in this interval, actually 30 to 39, these are the numbers which are included. Similarly here also 40 to 49, here also 50 to 59. The upper limits won't be included, but it will be included as the lower limits in the next coming intervals. Okay, so we have got this, right? So how we've converted it, I hope you understood it. So that's it for this session. Let's meet in the next session, which is the part 2 of this chapter. Thank you so much for watching this session. Let's meet in the next session.